Hello and welcome back. Let's do one final video on the area of a triangle. So most of us are probably familiar with the area of a triangle being given as 1/2 the height of the triangle times the base. So the area being 1/2 the height triangle times the base. Now the thing is that we can actually solve for h. So since we have this hidden little right triangle in here, I know what h is in terms of a. So h, excuse me. So let's do this step by step. So we've got the sine of a going to be the opposite side of a, which is h, divided by the hypotenuse, which is c. So we know that h is going to be c times the sine of a. So I can plug that in there. So the new formula for the area of our triangle is going to be 1/2. I'm just going to switch the order here. This is going to be b times c times the sine of a. So what you'll notice is that we have b and c are both different from a. So whatever a is, we have these two sides adjacent to it. And it turns out that this in general is the formula. So area of a triangle will have three formulas. So the area will be equal to 1/2, like we just said, b times c times sine of a, or this is also going to be equal to 1/2 a times c times sine of b. It didn't really matter. We could label this however we wanted to. I could switch all the a's with b's, for instance, and all the c's with b's, or the c's with a's. The labels don't matter as long as it's the two different sides with the third angle. We could also have 1/2 a times b times sine of c. So again, it doesn't matter what they are as long as you have two different sides and the angle that's between them, or the angle that's not opposite either of those two sides. So let's use this for an example. Let's find the area of an equilateral triangle. So if we take an equilateral triangle, we know that we've got a 60-degree angle here, we've got a 60-degree angle here, and a 60-degree angle up there. Let's say that each side length is just going to be 1. So the question is, what is the area of the triangle when we don't know what the height of the triangle is? So the area, we could just use this one right here. It's going to be 1/2 a times b times sine of c. So let's say that if this is going to be a and this is going to be b, then the sine of c here is going to be this angle right there. So this is going to be 1/2 a, which is 1, times b, which is 1, times the sine of a 60-degree angle. Anything times 1, so 1/2 times 1, that's just 1/2. Sine of a 60-degree angle is the square root of 3 over 2. This is one of our special angles that we should know. And when we multiply that out, we get the square root of 3 over 4. So this is the area of an equilateral triangle that has side lengths exactly equal to 1. We can actually go through and use the original formula for the area of the triangle as well. If I cut this angle directly in half, it'll go straight down, and now I have a 30-degree angle on that side and a 30-degree angle over there, since we cut that in half. So I can find the height of this side right there. So notice that I have a right-angled triangle here, and the sine of a 60-degree angle is going to be equal to the side opposite, which is h, divided by the hypotenuse, which is 1. So h divided by 1, well, that's just h. And the sine of a 60-degree angle, we had said, was the square root of 3 over 2. So the height is just the square root of 3 over 2. So the area, if I want to think of it in terms of 1/2 base times height, well, what's the base length of our triangle? That's just 1. And the height of our triangle is the square root of 3 over 2. And oh, look, we get the same thing again. So it's, in this case, it was pretty simple to get the same answer both ways. I find this formula is pretty simple to use. We don't have to do an extra step to try to figure out the height. Quite often we're given enough information to be able to plug that in anyway. And that concludes section 7.1.